Assalamualaikum and hi everyone. So for today we are going to do a presentation too about the vector and scalar. So for today we are going to do a topic that are related to mechanical engineering for DBM10013 Engineering Mathematics 1. So our lecturer is Puan Nur Zahirah binti Muhammad Ghazali and our group name is Grenade. So before we start our presentation too, we would like to introduce ourselves. My name is Nur Diyana binti Ali Tamar with metric number 08DKA21F1189.
Me, Aisyah Maisarah binti Ma'ali with metric number 08DKA21F1176.
And my name is Nurul Farhana binti Nur with matrix number 08DKA21F11X0.
Now, we would like to start our presentation with introduction for the topic. So, for the topic will be presented by Nurul Aisyah Maisarah.
Thank you, Diana. So, the topic of mechanical engineering. What is mechanical engineering? Mechanical engineering involves the design, construction, and operation of innovative machine, devices, and systems. Mechanical engineers are needed in oil and gas, automotive, manufacturing, entertainment, healthcare, and even aerospace industry. The field encompasses the making of both large machinery and small moving components. Vector and scalar. The definition of vector and scalar. Vector. Vector is a magnitude and a direction. For example, gravity is a vector. So for scalar is a simple quantity, no direction. For example, mass is 10 kilogram. I will pass it to Farhana to continue this presentation.
Okay, thank you, Aisyah. So the next is application of vector and scalar in selected area. We have oil tanker and tugboat as an example for vector and scalar topic. Okay, for the vector F1 is equal to 5000 I plus 5000 J Newton, and vector F2 is equal to 14 I Newton. So the resultant force is vector Fr is equal to F1 plus F2, and vector Fr equal to 5000 I plus 5000 J and plus 14,000 I and equal 9,000 I plus 5,000 J Newton. Okay, I will pass it to Diana.
It is actually 19,000 I plus 5,000 J. So, thank you, Nureen. So now I will continue the presentation too with the mathematical solution with drawing. So as we said before, that the example for mechanical engineering that we have is about oil tanker and two tugboats. So here we have F1 that have magnitude 5000 Newton for X1 and 5000 Newton for Y1. And this is the vector for resultant force, and this is the vector for force 2 that have magnitude 14,000 Newton for X2 and 0 Newton for Y2. So now we will move to vector and scalar topic. So now I would like to apply scalar dot product of two vectors. First thing first that we need to do is assume that force 1 is equal to vector A and force 2 is equal to vector B. Vector A is equal to 5000 I plus 5000 J. I and J is the Cartesian notation for vector and scalar. So, vector B is equal to 14,000 I plus 0 J. So, vector A dot vector B is equal to 5000 X1 and 5000 Y1 dot 14,000 X2, 0 I and 0 Y2. So it is equal to 5,000 times 40,000 plus 5,000 times 0. So it will get the answer 70 million So for the application for vector cross product of two vectors, we have vector A cross vector B, and we will do it like dominant for I, J, K. For the column I, we have 5,000 and 14,000. And for J column, we have 5,000 and 0. And K, we have K column, we have 0 and 0. This is actually for 3-dimension vector and scalar. So for I, we have 5,000 times 0 minus 0 times 0 minus J times 5,000 times 0 minus 14,000 times 5,000 plus K times 5,000 times 0 minus 5,000 times 14,000, and the answer is 0I minus J negative 70 million plus K times 70 million, and the answer is 70 million I plus 70 million K. So that is the answer for application vector cross product of two vectors. Next is the conclusion, and that will be presented by Nureen Farhana.
Okay, thank you, Dian. So the conclusion is multiplication of a vector by a scalar is the enlargement or reduction of a vector by the number of scalars is a unit of comparison. In rank Rn can be expressed as a linear combination of vectors basis. So this is the formula for scalar dot product, and application scalar dot product of two vector can form a scalar. Okay, that's all. I will pass it to Aisyah and Diyana to continue Q&A session. Thank you.
Thank you, Farhana. So I will start with Q&A session. The first question is how we know that the two vectors are perpendicular.
Okay, now I will answer Aisha's question, and the answer for that question is we can know that the two vectors are perpendicular by using vector cross product formula. Okay, so that is all for our presentation 2 for the topic vector and scalar for mechanical engineering that are related in DBM10013 Engineering Mathematics 1. Thank you our lecturer and all the viewers that are still with us until now. So see you guys in next presentation. Bye!